like water, and along the little passages are very fine hairs, which wave to and fro like reeds, and whenever the stirrup hits at the little window, the fluid moves these hairs to and fro, and they irritate the ends of a nerve, and this nerve carries the message to your brain. There are also some curious little stones called otoliths lying in some part of this fluid, and they, by their rolling to and fro, probably keeps up the motion and prolongs the sound. You must not imagine we have explained here the many intricacies which occur in the air. I can only hope to give you a rough idea of it, that you may picture to yourselves the airwaves moving backwards and forward in the canal of your ear, then the tympanum vibrating to and fro, the hammer hitting the anvil, the stirrup knocking at the little window, the fluid waving the fine hairs and rolling the tiny stones, the ends of the nerve quivering, and then, how we know not, the brain hearing the message. Is not this wonderful, going on as it does at every sound you hear? And yet, his is not all, for inside that cold part of the labyrinth, which looks like a snail shell and is called the cochlea, there is a most wonderful apparatus of more than 3,000 vine-stretched filaments or threads, and these act like the strings of a harp, and make you hear different tones. If you go near to a harp or a piano, and sing any particular note very loudly, you will hear this note sounding in the instrument, because you will set just that particular string quivering, which gives the note you sang. The airwaves set going by your voice touch the string because it can quiver in time with them, while none of the other strings can do so. Now, just in the same way, the tiny instrument of 3,000 strings in your ear, which is called Cortez organ, vibrates to the airwaves, one thread to the one set of waves and another to another, and according to the fiber that quivers will be the sound you hear. Here then, at last, we see how nature speaks to us. All the movements going on outside, however violent and varied they may be, cannot of themselves make sound. But here, in the little space behind the drum of our air, the airwaves are sorted and sent to our brain, where they speak to us as sound. Week 18. But why then do we not hear all sounds as music? Why are some mere noise and others called musical notes? This depends entirely upon whether the sound waves come quickly and regularly, or by an irregular succession of shocks. For example, when a load of stones is being shot out of the cart, you hear only a long continuous noise, because the stones fall irregularly, some quicker, some slower. Here a number together, and there 2 or 3 stragglers by themselves. Each of these different shocks comes to your ear and makes a confused, noisy sound. But if you run a stick very quickly along a paling, you will hear a sound very much like a musical note. This is because the rods of the paling are all at equal distances from one another, and so the shocks fall quickly one after another at regular intervals upon your ear. Any quick and regular succession of sounds makes a note, even though it may be an ugly one. The squeak of a slate pencil, along a slate and the shriek of a railway whistle are not pleasant, but they are real notes which you could copy on a violin. I have here a simple apparatus which I have made to show you that rapid and regular shocks produce a natural musical note. This wheel, figure 34, is milled at the edge like a shilling, and when I turn it rapidly so that it strikes against the edge of the card fixed behind it, the notches strike in rapid succession and produce a musical sound. We can also prove by this experiment that the quicker the blows are, the higher the note will be. I pull the string gently at first and then quicker and quicker, and you will notice that the note grows sharper and sharper till the movement begins to slacken, where the note goes down again. This is because the more rapidly the air is hit, the shorter are the waves it makes, and short waves give a high note. Let us examine this with two tuning forks. I strike one, and it sounds D, the third space in the treble. I strike the other, and it sounds G, the first ledger line, 5 notes above C. I have drawn on this diagram, figure 25, an imaginary picture of these two sets of waves. You see, the G fork makes 3 waves while the C fork makes only 2. Why is this? Because the prong of the G fork moves 3 times backwards and forwards while the prong of the C fork only moves twice. Therefore, the G fork does not crowd so many atoms together before it draws back, and the waves are shorter. These two notes C and G are a fifth on an octave apart. If we had 2 forks, of which one went twice as fast as the other, making 4 waves, while the other made 2, then that note would be an octave higher. So we see that all the sounds we hear, the warning noises which keeps us from harm, the beautiful musical notes with all the tunes and harmonies delight us, even the power of hearing the voices of those we love and learning from one another that which each can tell, all these depend upon the invisible waves of air, even as the pleasures of light depend on the waves of ether. It is by these sound waves that nature speaks to us, and in all her movements there is a reason why her voice is sharp or tender, loud or gentle, awful or loving. Take for instance the brook we spoke of at the beginning of the lecture. Why does it sing so sweetly, while the wild deep river makes no noise? Because the little brook eddies and purls round the stones, hitting them as it passes. Sometimes the water falls down a large stone and strikes against the water below, or sometimes it grates the little pebbles together as they lie in its bed. Each of these blows make a small globe of sound waves, which spread and spread till they fall on your ear, and because they fall quickly and regularly, they make a low musical note. We might almost fancy that the brook wished to show how joyfully it flows along, recalling Shelley's beautiful lines. Sometimes it fell among the moss with hollow harmony, dark and profound, now on the polished stones. It danced like the childhood laughing as it went. The broad deep river, on the contrary, makes none of these cascades and commotions. The only places against which it rubs are the banks and the bottom.